Okay, this is the Algebra 2 video lesson for section 5.5, Theorems about roots of polynomial equations. So we're going to solve equations using the rational root theorem, which states that if you have a polynomial, right, this is a number and then an x and then an exponent. This is the highest exponent, right, the degree of the polynomial, and then everything going down all the way till the last number, which is the constant. So the coefficient in front of the coefficient, it's called the leading coefficient of the one with the highest exponent. That number we're going to call an. That's a coefficient, it's just going to be a number. And then this AO is the A0 is the constant, which is just the number that doesn't have an x. So like if this is a polynomial, right, the leading coefficient is the 2, because this 3 is the highest number here. So this is the leading term. So my leading coefficient is 2, and then my constant is 5. This doesn't have an x with it, right? Okay, so the rational root theorem says that any of the rational roots that of this function, or the answer to this, a root being where when is this equal to 0, are going to be are the form p over q, where p is the integer factors of the constant, and then q is the integer factors of the leading coefficient. So in this case, let's do this one. There's a lot of factors here. Let's do it this one. Okay, so what are the rational roots of this? So first we're going to look possible rational roots. Okay, so our possible rational roots are going to be p over q, where p is going to be the factors of this 5, and they're plus or minus 1 and plus or minus 5. There are no other factors of 5. So these numbers are either plus or minus 1 or plus or minus 5. And then that's going to be divided by factors of the leading coefficient, which is 2. So the factors of 2 are plus or minus 1 and plus or minus 2. So, oops, that's an equal sign. Plus or minus 1, plus or minus 2. So then any combination of these. So I like to just start with the first one. 1 over 1 is 1, and it's plus or minus 1. 1 over 2 is 1/2, plus or minus 1/2. And then the combinations here, 5 over 1 is plus or minus 5, and then 5 over 2 is plus or minus 5 over 2. So these are our possible rational roots. So to find our rational roots, you only have to look at these 1, 2, 3, 4, 5, 6, 7, 8 numbers. And what you do is you take each one and you plug it in for x, and you see if it equals 0. The book wants you to do all that by hand. They say like without a calculator. Basically, they don't want you to just graph it and pick the answers. But I think we can do it with Desmos. And so what you're going to do is put this function into Desmos. So you are going to use the calculator, but you're going to use it to just plug these values in. You're not going to just look for the answers. And so you're going to type in Desmos f parentheses x parentheses, and then you're going to have equals 2x cubed minus x squared plus 2x plus 5. So you type that into Desmos. And then now that you've basically defined this f of x, you can then type in the next box, like say this is 1. In the next box, you can type in f parentheses and then put your 1. And it will give you an answer. And then do your negative 1. And then it'll give you an answer. And you can actually just keep typing over this one, typing over it with your new next answer. 1/2, negative 1/2. And go through these, and if you hit any zeros, that means it's a rational root. Okay, so I'm going to go do this in Desmos. I'll show you all the possible, and then we'll see if there's any zeros. Okay, so here, this is what I did. I typed it in like this, f of parentheses x, right, equals this, and now you can just do f, and you can plug that value in. And when you're doing this in Desmos, you can just put 1 in, and then do the negative 1, and just keep changing this number and just checking this number, but I just wanted to show you all 6 of them. And you can see here that negative 1 is a 0. So that means the only rational root is negative 1. And you only have to check the 6 because these are the only possible rational roots. And so when the question says, what are the rational roots? You can say negative 1. It's the only one. Okay? And so, let's get rid of this. And why don't you guys try this one on your own? So I guess I'll leave this up so you can push pause to figure out the possible rational roots, and then go into Desmos and see if you can find the rational roots of this function here. Okay, so press pause and then check back for the solution. Okay, so here For this one, the factors of our leading coefficient are plus or minus 1 and 3, and the factors of our constant are plus or minus 1, plus or minus 2, 4, and 8. So these go on top, these go on the bottom, and then you use every combination, right? 1 over 1 is 1, 2 over 1 is 2, 4 over 1 is 4, 8 over 1 is 8, and you just do plus or minus both of those. And then you move on to the 3 1/3, 2/3, 4/3, and 8/3. None of them repeat, so there's actually, 1, 2, 3, 4, 5, 6, 7, 8 times 2, 16 you need to check. So when you put this into Desmos as your f of x, then you just try every single one of these. 1, -1, 2, -2, 4, and all 16. And when you do that in Desmos, you find that there's only one and it is 2/3. So that's the only rational root. Okay, so for this example, we're going to do the same thing, looking for rational roots. But once we find one root, instead of testing all of them, we can then, once we have one, we can use synthetic division to divide out, and then we can use other methods, right? Since this is third degree, or basically you find as many roots as you can to get to second degree, and then you can use our methods to solve for second degree polynomials. So let's do the same thing for this one that we just did, but let's stop after we find one. And then we'll do synthetic division to find the others. So in this case, we have P over Q. My P's are plus or minus 1 and plus or minus 2. And then my Q's are 1, 3, 5, and 15. So plus or minus 1, 3, 5, and 15. So you can see there's a ton of these, right? There's 1, 2, and then 1/3, 2/3, 1/5, 2/5, 1/15, 2/15, and then like the positive and plus or minus of all of those, right? So there's a bunch here. 1, 2, 3, 4, 5, 6, 7, 8, so 16. So let's just start with a couple. Once we find one, then we can stop and do it and use another method. Okay, so when we do this in Desmos, we find, if we're going in order, we find that 2 is a root. So we'll stop at 2, and then that means that a factor, one of my factors is x minus 2, right? So we can, when we know it's a root, we can use synthetic division to divide it out and see what's left. So we have 15, -32, 3, and 2, 3, 2, 1, 0. Okay, bring your 15 down, multiply that, 30, minus 2, minus 4, minus 1, -2. Here we can see that that works. And now we have 15, remember x squared, since this is x third, you go down 1, x squared minus 2x minus 1 equals 0. So we can try to factor this. We can look for two numbers that multiply to 15 and add to -2. -15, -2, it's going to be -5 and 3. So this becomes minus 5x plus 3x minus 1. And then we can pull out a 5x here. We get 3x minus 1, and then we can pull out just a 1 here. So plus 1, 3x minus 1. And then our two factors are 3x minus 1 and 5x plus 1. So then we see here that this is a 1/3 and this is a -1/5. So those are our other two. And then this one is 2, right? We found 2. So those are our three rational roots. And you can see that 1/3 is here and -1/5 is here. So we could have gone through all 16 and typed them through, but instead, once you find one, you can divide it out using synthetic division and then factor your answer. Okay, so please try that on this problem here. So just use Desmos to find one root, and then divide out that root using synthetic division to find any other rational ones. Actually, you can also find irrational ones too, and complex ones as well, which we'll get to. Okay, so try this one, press pause on your own, and then check back for your solution. Okay, so for this one, we found these 12, and if you start putting them in, you'd find pretty quickly that -1 worked. So once you know that -1 is a root, you can use synthetic division to divide it out and then factor what's left. And then you can find the other factor, the other roots as 2, and then -3 over 2 makes this 0. Remember, that's just taking this factor, 2x plus 3, setting it equal to 0, and then solving for x. And if you divide both sides by 2, you get -3/2. Okay? So then, we've discussed rational roots. We also have irrational roots and complex roots. So irrational roots are going to come of the form a plus the square root of b, and then they come in pairs. So that's what this conjugate root theorem is talking about. That if you have a root that's a plus the square root of b, then a minus square root of b is also a root. So and these are conjugates, so they always show up in conjugate pairs. This is also true for complex roots. So if a plus bi is a complex root, then a minus bi is also a root. So let's look at this first problem. It says a quartic, that's a fifth degree polynomial. Sorry, fourth degree. Fourth degree polynomial has rational coefficients if the square root of 2 and 1 plus I are roots of, when this is equal to 0, what are the other two roots? Well, if we know that square root of 2 is 1, right, we have a plus b root, a plus root b, that means a minus root b is a root. So if we have 0 plus root 2, then we also have 0 minus root 2. So then this is a root, then this is a root, and then 1 plus I means also 1 minus I. So those are our 4 roots for our quartic polynomial. So try this one on your own here. If you have a cubic, that means it's degree 3, has real coefficients if these are our 2 roots. What's the one additional root? So press pause, try this on your own, and then check back for the solution. Okay, so since this root is rational, that doesn't tell us another conjugate pair, but this one's complex, so this gives us the 3 plus 2i. So that's the one additional root there. And that is it. So you just have 5 problems to practice here. Enjoy.